Students, today we are going to start amines. Amines, these are derived from ammonia. The parent compound of amines is ammonia, NH3. Amines are the derivatives of ammonia, in which 1, 2 or all 3 hydrogen atoms are replaced by either alkyl group or aryl group. The parent compound of amines is ammonia. Substitute hydrogen atom with alkyl group. What we got, students? NH2. Further substitute next hydrogen atom with alkyl group. We got R2NH2. Further substitute the remaining hydrogen atom with alkyl group. At last we got R3N. We call them amines, 1 degree, 2 degree and 3 degree. Classification of amines. Friends, in ammonia it is clear there are 3 hydrogen atoms. If one hydrogen atom is replaced from ammonia, the amine is 1 degree. If 2 hydrogen atoms are substituted, it is 2 degree amine. Or the 3 hydrogen atoms are substituted from ammonia, we call it 3 degree amine. Primary, secondary and tertiary amines. At first, we discuss the nature of alcohols. Alcohols contain hydroxyl group. Alcohols contain hydroxyl group, OH group. Now it's clear what is the nature of this alcohol. We check the nature of alpha carbon, students. The alpha carbon which is in link with functional group, that is your alpha carbon. It is 3 degree. It is in link with 3 other carbon atoms. We call it as 3 degree alcohol. But students, in case of amines, we will not focus on the nature of alpha carbon. We will look only at the number of hydrogen atoms which are in link with nitrogen. Now it is called as amines. We don't check the nature of alpha carbon. Amines, these are derived from ammonia. Ammonia contains 3 hydrogen atoms. Students, in this case, 1 hydrogen atom is replaced. 2 hydrogen atoms are in link with nitrogen. It is 1 degree amines. If 1 hydrogen atom from ammonia is substituted, we call it primary amine. 2 hydrogen atoms are substituted, secondary. All the 3 hydrogen atoms are substituted, it is 3 degree amines. What is the nature of this amine, students? It is 1 degree amine. After this, next, nomenclature. In nomenclature, we have 2 rules. One is common system and second is IUPAC system. According to IUPAC system, we use the term alkane amine for their names. Alk is word root. After word root, we add primary suffix and then we add secondary suffix amine. And in common system, we call them alkyl amines. Let's practice some. At first, what is the nature of this amine, students? Ammonia contains 3 hydrogen atoms. 2 are present in this compound. It means only 1 hydrogen atom is substituted. We call it 1 degree amine. We will follow lowest number rule. Definitely we will number from this end because it got least 3 numbers. 4, 5, 6, 7. That's the parent chain of 7 carbon atoms. We use the word root hept. Saturation N. E delete because vols will not occur continuously. Hexane 1 amine. Hexane 3 amine. It is in link with third carbon of parent chain. Heptane 3 amine. Friends, next, what's the nature of this parent amine? This amine is 1 degree, 2 degree or 3 degree. We call it 3 degree amine because all the hydrogen atoms from ammonia are substituted. It is 3 degree amine, students. Stacked longest chain. It is a possible longest chain of 3 carbon atoms. 1, 2, 3. Now these are the substituent groups, side chain, but they are in link with nitrogen atom of amine. It means both are same. N, diethyl. Because they are in link with nitrogen atom, so we use N letter, not the number. N, diethyl. Now word root prop. Saturated in 1 amine. N diethyl propane 1 amine. Then these are aromatic amines. You already know it is aniline. C6H5CH3 toluene. one hydrogen is replaced, we call it benzyl group. Now it is called benzyl amine. Both are primary, aromatic benzyl amine, BENZYL. It is 1 degree, students. It is again 1 degree because two hydrogen atoms are with nitrogen, only one is substituted from ammonia. After this, next, students, methods of preparation. In methods of preparation, at first we already have done in haloalkanes by the reduction of cyanides. Students, when we reduce cyanides, what we got? 1 degree amines. Either we use lithium aluminium hydride or Mendes reduction reaction, that is proceed with sodium and alcohol. Proceed sodium and alcohol, it is called Mendes reduction reaction. Triple bond will reduce to single at first because it is reduction. Reducing agent will supply hydrogen atoms to stabilize the compound. Two hydrogen atom adjust with carbon and two with terminal nitrogen. It is clear it is 1 degree amine. It is called Mendes reduction reaction. If we use the reducing agent sodium and alcohol, it is Mendes reduction reaction. It will supply nascent hydrogen. Again, either you will use sodium alcohol or simple lithium aluminium hydride, CH3CH2CN. Whenever CN is given, it is clear there is triple bond link, students. In cyanide there is always triple bond link. Again same, triple bond be reduced to single, CH3CH2 CN. Two hydrogen atoms goes to carbon and two hydrogen. It will supply nascent hydrogen because it is reducing agent. Again we got 1 degree amines. Now it is for your assignment, complete this reaction. Proceed it with sodium and alcohol, cyanobenzene. Same, triple bond be reduced to single, two hydrogen atom stabilize this carbon and two to this terminal nitrogen. You can easily mention the product. Students, if we reduce isocyanides, then we got 2 degree amines. If we reduce cyanides, we got 1 degree amine, sodium alcohol, RCH2NH2. But it is isocyanide, RNC. It is ambidentate nucleophile, cyanide isocyanide. 2 covalent bond and 1 coordinate bond. Friends, what will happen? Same. Triple bond reduced to single, but it is CH3NC. What is the valency of carbon? 4. It means 3 hydrogen atoms strike to carbon and 1 hydrogen atom approach to nitrogen. It is clear. It is 2 degree amines because 2 hydrogen atoms from ammonia are replaced. Its IUPAC name is N-methyl methane amine. If we reduce cyanides, we got 1 degree amine. But if we reduce isocyanide, we got 2 degree amines. After the second, students, method from amides. From amides, amides are derived from acid. The parent compound of amides is acid. You know acids, they contain carboxyl group, RCOH. If we substitute OH group with NH2 group, the resulting compound is called amide. Substitute NH2 with NH2, what we got? RCONH2, that is acid amide or simply amide. Acid amides, they are derived from acids. Now it's important naming reaction in your syllabus. It is called Hofmann degradation reaction. Why we use the term degradation? After the completion of reaction, I will clear. What's the name of this chemical reaction? Hofmann degradation reaction. Students, in this reaction, 1 degree amines are prepared. Primary amines are prepared by treating amide with bromine and base. When we treat amide with bromine and base, we got 1 degree amines. The reaction is called Hofmann degradation reaction. It means, what are the participants? 1 degree amine, bromine and base. Under the reaction condition, what will happen, students? The carbonyl group eliminates from this amide. What is left? It is clear, RNH2. RNH2, primary amine. Then we have to mention byproducts. It is clear, students. Metal, strike to non-metal, KBr. All times I say, if we use alkali, one of the product is water. And one more byproduct is formed. It is potassium carbonate, K2CO3. Potassium carbonate, students. What will happen? Carbonyl group eliminates from the parent amide. When it eliminates in alkaline medium, it will changes to carbonate ion. It changes to carbonate ion, definitely metal will strike to it. So the resulting product is K2CO3. Friends, we have to balance bromine 2 times 2, potassium 2 and 2, 4. We apply always hit and trial method. How many oxygen atoms? 4 and 1, 5. 1, 3 in carbonate salt and definitely 2 in water. Now it is balanced. What we call it? Hofmann degradation reaction. That is, amides are treated with bromine and base. Please look here again. It is ethane amide, also called acid amide. Acid amide means derived from acetic acid. Acid amide. When we treat it with bromine and base, complete the reaction, it is clear. Amide will lose carbonyl group. What is left, students? CH3NH2. CH3NH2. Because carbonyl group eliminates, the byproducts are same. KBr plus water plus K2CO3. KBr plus water plus K2CO3. It is called Hofmann degradation reaction. Why we call it degradation reaction? All of you know degradation means decrease. Friends, when we make amine from amide, the carbonyl group eliminates, means because the amine formed has one carbon atom less than the parent amide. So we call it degradation reaction. In amide there are 2 carbon atoms, but the resulting amine which is formed, it has only 1 carbon. It is called degradation reaction because amine formed has 1 carbon atom less than the parent amide. Means there is decrease in the number of carbon atom. There is decrease in the number of carbon atom. So we call it degradation reaction. Now students, again it is for your assignment. It is aromatic amide derived from benzoic acid. We call it benzamide. Benzamide with bromine and base. Same reaction do. Eliminate carbonyl group, mention byproducts. And one more key point. Whenever we have to convert amide to amine, we always approach this reaction. That is the simple route. Convert benzamide to aniline. Students, do you know benzamide means it is the derivative of benzoic acid. Benzoic acid C6H5COH. Benzamide means C6H5CO NH2. What we have to make? Aniline. What is the formula of aniline? You know already. C6H5 NH2. Whenever we have to convert amide to amine, only you have to write on the arrow bromine and base. Definitely you will get 1 marks. If it is of 1 marks, that is the route. No need to mention byproduct, it is conversion. What I told you, whenever we have to convert amide to amine, we apply degradation reaction. It is called degradation reaction because amine has 1 carbon less than the parent amide. After this, next from haloalkanes. First we do reduction of cyanide, second from amides degradation reaction, and third from haloalkanes. Students, when haloalkane in excess is treated with ammonia, we got a mixture of primary, secondary, tertiary amines. It is nucleophilic substitution reaction. That is, what will happen? We use haloalkane in excess. Nucleophilic substitution. HBr eliminates as byproduct. Halogen atom is substituted by the negative part of attacking reagent. What we got? C2H5NH2. It is clear it is primary amine. 1 hydrogen atom is substituted. Students, if haloalkane is not in excess, then the reaction will stop at this stage. In this reaction, it is mandatory to write excess at the base of haloalkane. If it is in excess, further reaction proceed. It will now again strike on primary amine because we have written excess. Further it strike nucleophilic substitution. HBr eliminates as byproduct. It is clear. Number of hydrogen atoms with nitrogen decrease and alkyl group increase. Now what will be formed? C2H5 twice NH. And you know it is 2 degree amine. After this again haloalkane was in excess, it again strike. HBr eliminates as byproduct. Number of hydrogen atoms decrease and alkyl group increase. At last C2H5 thrice N. It is clear it is 3 degree amine. Friends, tertiary amine again strike with halolcane. This tertiary amine again strike with halolcane because nitrogen still has one lone pair. RX carbocation, it will attack on nitrogen atom, leads to the formation of quaternary ammonium salt. Please look here, one more alkyl group increase, C2H5 4N. Definitely positive charge, carbocation attack and anion part is Br negative. It is called quaternary ammonium bromide. Amines 1 degree, 2 degree and 3 degree. After 3 degree there is another class called quaternary ammonium salts. Now students, what happen? Halolcane is in excess, means it further undergo reaction with 3 degree amine. At last what we got? Quaternary ammonium salt, C2H54 N. It is positive complex and anion part is Br negative. It is your naming reaction. We call it Hofmann's ammonolysis reaction. Previous was Hofmann's degradation reaction. It is Hofmann's ammonolysis reaction. Hofmann's ammonolysis reaction. A mixture of primary, secondary, tertiary amine or even quaternary ammonium salt is obtained. Friends, its limitation, pure primary amines are not obtained. It gives a mixture of amines. I hope the concept is clear. Hofmann's ammonolysis reaction. In this reaction, a mixture of primary, secondary, tertiary amine or even quaternary ammonium salt is obtained by treating halolcane in excess with ammonia. What happened? In the presence of ammonia, lysis, so we call it ammonolysis. If we have to obtain pure primary amines, then we use Gabriel Thalamide synthesis reaction. It is again important, Gabriel Thalamide synthesis reaction. In this reaction, pure primary amines are prepared. Pure primary amines are prepared from thalamide. You know it is phthalic acid. Benzene 1,2-dicarboxylic acid. It is called as phthalic acid. From phthalic acid we can easily derive thalamide, that is substitute hydroxyl groups. Changes it to amide. This compound is called thalamide, students. Pure primary amines are prepared. We start from thalamide, which is the name in the given chemical reaction. We treat it with base KOH. What will happen? We use alkali. I told you water eliminates. HOH. It is covalent compound. Now ionic compound is formed, that is potassium salt of thalamide. C6H5 CO CONK. It is thalamide. HOH, water eliminates. There is huge electronegativity difference. It is ionic compound. Potassium salt of thalamide. Friends, then potassium salt of thalamide is treated with halolcane. Now it's clear. Metal will strike to non-metal. KBr eliminates as byproduct now. KBr eliminates as byproduct and we got an alkyl thalamide. KBr eliminate and alkyl group strike on nitrogen, covalent compound again, and alkyl thalamide. And at last, fourth step, complete hydrolysis, water in dilute acid. You know water contain H and OH. OH and H. Water contain OH ions and hydrogen ions. OH and H. Please try to understand. Complete hydrolysis, students. This will happen. Now it is clear. Nitrogen is more electronegative than carbon. It will have negative charge and carbonyl carbon positive. Nitrogen more electronegative. Negative charge, carbonyl carbon positive. Definitely on carbonyl carbon, OH group strike. And on nitrogen atoms, hydrogen atom strike. When hydrogen atoms strike, what we got? C2H5NH2, pure primary amine. C2H5NH2. It is clear, students, C2H5NH2 plus the byproduct is phthalic acid, which can be reused to obtain thalamide. COOH, COOH. From this we can again synthesize thalamide. So we call it thalamide synthesis reaction. Again please, it is the name of the reaction, thalamide synthesis reaction. Start from thalamide, treat it with alkali. What you got? Potassium salt of thalamide. Then use haloalkane and alkyl thalamide. And at last complete hydrolysis. Easy steps students, you can easily do. Gabriel thalamide synthesis reaction. After this, next students, next method of preparation, easy, by the reduction of nitro compounds. When we reduce nitro compounds, loss of oxygen reduction and addition of hydrogen reduction, what we got? Amine. That is reducing Z may be lithium aluminum hydride. It will supply nascent hydrogen. Oxygen will reduce, it will form water. Twice, because there were 2 oxygen atoms in the nitro group. Nitro compound contain 2 oxygen, 2 water, 2 to the 4 or 2, 6. It will supply 6 nascent hydrogen, which is a function of reducing Z. Whenever we reduce nitro compounds, the resulting product is amine, students. That is the concept. Now please complete the reaction. It is nitroalkane, lithium aluminum hydride. Now it means it is reducing Z, reduce nitro compound to amine plus 2 water. Convert nitrobenzene to aniline. We will use reducing Z. It is nitrobenzene. Please write reducing Z, or you can also use active metals like zinc, iron, tin in the presence of concentrated HCl. Again, it will supply nascent hydrogen by the use of active metals in concentrated HCl. Again, what will happen? Nitro compound, nitro group will reduce to amine. We got C6H5 NH2 plus water. It supply nascent hydrogen. That's the reduction. What is the product of the reduction of nitro compound? Students, amine. After this, complete the reaction. Again for your assignment, nitroethane, we are using active metal in concentrated HCl or lithium aluminum hydride. It will reduce nitro compound to amine. Do it, students. After this, students, it is important. Please try to understand. It is 1,3-dinitrobenzene. You know, 1,3-dinitrobenzene. Complete the reaction. Lithium aluminum hydride. It is reducing Z. It will reduce nitro compound to amine. Reduce nitro group to amine. What we got? NO2. It is reduced to NH2. It is again reduced to NH2, students. But main important is this one, which we are going to do now. That is selective reduction. What I say? Selective reduction, students. The selective reduction of one nitro group in dinitro compound. There are 2 nitro groups. Both are reduced if we use lithium aluminum hydride, if we use iron in concentrated acid. But if we have to reduce only one and we have to protect second, we will go for selective reduction. And selective reduction, it is achieved in the presence of hydrogen sulfide. Only you have to mention this one. In the presence of hydrogen sulfide in aqueous or alcoholic ammonia. If we go by this route, use hydrogen sulfide in aqueous or alcoholic ammonia. ALC means alcoholic. What will happen? One nitro group is protected and second will reduce to amine. It means in this case the product is 1 will reduce to NH2 and second is protected, remain as NO2. We got meta-nitroaniline. Amine, they are activating ortho and para-directing. But if we go by this route, we got meta-nitroaniline. Selective reduction of one nitro group in dinitro compound is achieved by using, definitely you will take which reducing agent, H2S in alcoholic ammonia or H2S in aqueous ammonia. It is important question in competitive exams. Please do it. Convert benzene to meta-nitroaniline. Students, benzene nitration, you got nitrobenzene. Again nitration, you got, it is deactivating group 1,3-dinitrobenzene. Then use it. Definitely you got meta-nitroaniline. Complete up to this. Thank you.